Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to another problem of electro-pneumatic circuit. This is a very unique problem which includes the pressure sensor. So let's see the problem statement first. Here the problem states that components are to be stamped using a stamping machine. In other words, a double acting cylinder. So this is my double acting cylinder named A. A double acting cylinder, they already mentioned that, is used to push the die attached down to a fixture when two push buttons are pressed simultaneously. So if I have to start the operation, I have to push two push buttons simultaneously. Then it says that the die is to return to the initial position upon reaching 0.6 megapascal pressure. Here I have to monitor the pressure also as sensed by a pressure switch. See, a pressure switch is used to sense the pressure and 5 seconds delay. Develop an electro-pneumatic control circuit to implement the control task for stamping operation. So what I have to do is that I have to press two push buttons. Then this cylinder will start to extend. When A1 position is reached, then the pressure in the supply line starts to increase 0.2, 0.3 and increasing to 0.6 megapascal. When the pressure reaches 0.6 megapascal, I have to sense that and somehow I have to stop this circuit after 5-second delay. Let's see how we can achieve that. As I have to control the pressure, so I'm going to use a meter in circuit in the pneumatic part. I already have a video on meter in and meter out control. You can watch that. It will be helpful for you. So let's start. So this symbol states that the inflow to the cylinder will be controlled. This side will be free and I have to give a pressure sensor on the left side. So this is my pressure sensor. It is sensing the pressure on the left port or the input port. Let me give a identification. So suppose this pressure sensor is P. Now for the electrical part. The problem states that I need two push buttons to start the operation. So construct a latching circuit with that. So this is my latching circuit. This is my push button 1. This is my push button 2. I have to press this simultaneously to start the operation. And I have a break contact to break the circuit operation. Now let's identify all of this. So this is PB1, PB2. This relay is K1 and this make switch is sensing K1. I will identify the break switch later. Now for the next branch. So this make switch is also sensing K1. This is my relay K2 and it will trigger a solenoid. So this make switch will sense K2 and this is my solenoid Y1. Alright, now for the pressure part. I have to construct another branch and I need a delay timer which has 5-second delay. This make switch is triggered by the pressure sensor. This is the symbol is triggered by the P pressure sensor. And when this pressure sensor is triggered, the delay timer activates. It countdowns from 5 to 0. We have a relay coil inside this delay timer. So I will name that K3. And this K3 triggers another branch. This make switch is triggered by K3 and it will energize a solenoid Y2, which will help to retract the cylinder. So let me explain the whole working of the circuit. Another thing I forgot is that this brake switch is activated by a timer. So this one is K3 and I have to also give the symbol in this make switch. Now let me explain. To start this operation, I have to press PB1 and this is PB2. Okay, so start this operation, I have to press both PB1 and PB2 simultaneously. Then a connection is made, energizing the K1 relay. This contact closes, making a permanent connection through the circuit. Now this K1 contact also closes, energizing K2 relay. Because of that, this make switch triggered by K2 also closes and connecting this circuit, energizing Y1. So the left side of this 5x2 DCV actuates. Flow will go through this restricted section to the cylinder and extending the cylinder A. Here, the pressure sensor is sensing the pressure of the flow. When this pressure sensor senses 0.6 megapascal, then it gives signal to this make switch. This make switch closes, making a connection, activating this timer relay. This timer counts down from 5, 4, 3, 2, 1, 0. Then this timer relay gives signal to this side and this side. On the left brake switch, the contact is open. The latching circuit gets deactivated. So K1 is open now, K2 is not energized, Y1 is not energized. So there is no flow on the left side of this 5x2 DCV, but this make switch closes, making a connection. Y2 energizes and there is a connection on the right side of this 5x2 DCV. Because of that, the cylinder retracts to its initial position and the operation completes. To start the operation again, I have to press this PB1 and PB2 simultaneously again. So here is a question for you. If you want to make this circuit automatic, what kind of change you have to make? Think about it and write in the comment. And if you are having hard time with it, then say in the comment. I will make a separate video on how to automate this whole circuit. So just pressing the PB1 and PB2 push button, the operation becomes automatic and I can manually stop this circuit by using a push button. Or to make things even more complicated, you can automate this circuit for 50 cycle or 100 cycle and after that it will stop on its own. So you definitely have to use counter on that one. These are very interesting problems. You should give it a try. But if you are having problem, then please share with me. I will guide you through it. So let's see in the FluidSIM software. So I have this circuit already made. First, I would like to point out some things. This is a pressure switch. See, a pressure sensor. It's a type of pressure switch. I have given identification as P. Here you can see that switching pressure is 0.5. I have to use 0.6 here and it is in megapascal. I checked the D and U so that the text shows here. This is nothing important. And I have a metering circuit here. Here you can see the opening level is 2. So we have 98% restriction of the flow. And this make switch is sensing the pressure sensor. So if I double click this, then you can see the related object is P here. So okay. And this is my counter relay. You can see the delay time is 5 and the identification level is K2. So let's simulate. Now I will press PB1 and PB2 simultaneously. See what happens. See, the pressure reaches 0.6 megapascal and the timer start. To see how pressure rises, I have to give a measurement probe to this side. Left click on this pressure, then left click on the line and again left click here. Now we can see how pressure is changing in real time. Now let's start simulate again. Pressing PB1 and PB2 simultaneously. See, the pressure is rising 0.4, 0.5, 0.6, and this switch closes. The timer is started, counts to 0, and this K2 and K2 closes and opens respectively, and the cylinder returns to its initial position. So that's the overall solution I showed you in real time. I hope it was helpful. If you are having trouble constructing this circuit, please let me know. That's all for this video. See you in the next one. Allah Hafiz.